Well, thank you all for coming to listen. I'm Rod Stellmuller with Aviatrix, and today I want to go through a couple of things. Who is Aviatrix and what do we do? For a lot of people don't know about us. And we'll talk a little bit about security being embedded into the cloud network, which I think is a real change in the way things are being done, and I think you'll see some benefit in that. And then I'll give a couple of use cases where we work together with AWS very well in terms of working with their native constructs and adding some capabilities together. Then we'll probably have a little bit of time to do Q&A at the end. So Aviatrix. I like to introduce Aviatrix through our customers, give you an idea of the kind of customers that we work with. Here you can see in just about every vertical out there, we've got 60 of the Fortune Global 500. About 60% of our customers are in a single cloud today, but a lot of them are doing this in a way so that they can build an architecture that gives them a multi-cloud architecture. And we have about 17,000 Aviatrix certified engineers, or ACEs, that have gone through training and are certified in this multi-cloud networking capability. Gartner has said publicly that you should shortlist Aviatrix if you're looking for that advanced networking functionality that's missing from the native cloud capabilities. We are a big AWS partner. We're both networking competency and security competency, which is interesting because there's only about 5 companies who actually have both of those certifications. Normally, you're either a network certified or competent or a security competency partner. And this is something that they don't give away lightly. This takes 4 or 5 months to go through working with product management teams to verify that everything you're doing is what you're saying you're doing. So let's talk about secure cloud networking, kind of what that is and what we do. So the way you build networking in each one of the clouds is different because the underlying constructs in each one of the clouds are different. So what we do is we have a controller that you download from the cloud marketplace, and this talks to the native constructs. So for instance, VPC route tables or VNet route tables. And then we add advanced networking and security on top of all the clouds to be able to deliver it consistently across all clouds. So for instance, we're replacing the transit gateway in AWS, and we replace vWAN in Azure and NCC in Google, so that now the way that you build networking in AWS is the same in Azure, it's the same in Google, it's the same in Oracle, same in Alibaba Clouds. Now, what that does is it gives you consistent visibility and troubleshooting for the infrastructure teams who need to be able to support applications running in these different clouds, but want to manage the infrastructure, the networking and security in a consistent way. It also gives them consistent security across all the clouds for network segmentation and things like that. And it gives you consistent automation. So we have a single Terraform provider that you can write one infrastructure as code module, and it will work across all the clouds. So building into your CI/CD pipeline and be able to do automation becomes a lot easier. Now, you'll hear other vendors talk about multi-cloud networking solutions, but what they mean is that they connect to multiple clouds. They stop at the cloud edge and then pass you off to those native constructs that I was talking about. So the manageability, the consistency is different in each one of the clouds. It's not what I was talking about where we give consistency across all the clouds. So now let's talk a little bit about embedding security into the cloud network. One of the things that happens when you build with Aviatrix is we become the data plane. So we see every packet that's going across the network. And we can compare the source and destination address to a database of malicious IPs. Now, we don't make that database. It's made by Proofpoint, same guys that AWS GuardDuty uses. But what this allows us to do is identify anywhere across the multi-cloud network that something is talking to a malicious IP or just began talking to a malicious IP. And as soon as we see that, because we control the data plane, we can put a blocking rule in and shut that communication down immediately. Now, this is what it looked like to one of our customers about a year ago, and they were very surprised to see all of these things talking to their cloud. In fact, a lot of people look at this picture and think, oh, that's a big global company. But this was a manufacturing company in Oregon, and all of these are malicious IPs talking to their workloads. They ended up discovering Bitcoin mining and Tor servers and botnets that were doing DDoS attacks, and none of their other security products saw any of this because it's all where it has to go through a single inspection point, and if it doesn't go through the inspection point, you don't see it. But because we're the data plane that everything has to go across, we see all of this traffic. Now that's how we discover known threats that are in a database, but now what we're doing is doing baselining the application environment so that we look for anomalies that are deviations from normal. So we establish over 2 weeks what's normal for this application environment and looking for things like ports and protocols. And then a little bit later, all of a sudden we start seeing new ports and protocols. We're going to highlight that. We won't shut it down because it could be perfectly normal, but more likely it's actually malicious code moving between machines using some obscure ports that normally wouldn't be seen, but we see it because it's going across our data plane. Now these are some of the pictures of some of the visibility that we provide, and one of the reasons that a lot of people buy us even in a single cloud, and that is the ability to do a dynamic topology map. You can see latencies on all the connections. You can drill in and do packet capture and ping and trace route and all the things that the network guys love doing but have found hard to do in the cloud. We can go back in time. So for instance, this is what we call topology replay. So we're looking at if everything was working yesterday and now it's not, I can scroll back in time and see exactly what changed and who changed it. I see every flow on the network, so I can search and sort on source, destination, port, protocol. I can go all the way down into TCP flags and be able to troubleshoot application issues. Or I can look at all these flows as a heat map. And the security guys love this because they kind of go, oh, okay, I understand why we're talking to something in South America, but what's going on up here in northern Siberia that I should be concerned with? And they can drill in and see exactly what that is. Usually it's scanning for open ports and things, but if they see a connection established, they know they can shut that down. Now we support all kinds of different business values across a bunch of teams. I won't go into the details of this, but if you want to know more, stop by and we'll go into details on what kind of business value we provide across the teams. So now let's talk a little bit about some of the use cases that are with AWS and better together. So we've talked about the operational visibility a little bit there already. We've talked about, multi-account, multi-BU, multi-region, multi-cloud networking. We talked a little bit about threat IQ with ThreatGuard being able to identify those threats. But let's talk about some of the things that we work with besides that. So when we build the network, we actually build a high availability active network. So we'll put a gateway in each one of the availability zones in a VPC and then do that same thing at the hub connection. So now I build a full mesh connection. So where you'd normally get a 50 gig connection, you now get a 100 gig connection while it's in active. And then if any of the availability zones go down, you'll drop down to the normal 50 gig that's connected there. And we can do that in a region or across regions. So if you need that kind of connectivity across regions, and this is all in the AWS infrastructure. Now let's talk a little bit about the AWS Direct Connect. So a lot of you have direct connects either through a partner like Equinix or directly from your data center, and you might buy a 10 gig link. But if you want to encrypt that, it's going to go down to 1.5 or 1.25 gig in terms of the encrypted link. We can actually get you up to wire speed up to 25 gig on that connection because we're aggregating tunnels and processing capacity. And that's going from on-prem into the cloud. And then inside the cloud, we can go up to 100 gig. I think when I did this presentation, it was 90 gig, but it's up to 100 gig now that we can do inside the cloud. Now, in terms of Copilot visibility, I showed a little bit of the Copilot visibility, and the way we do that is that we're looking at information that's coming from native constructs like the route tables and information that our gateways are collecting and presenting that in a nice visual way. Now I'm going to show you something called App IQ, because this is something that's really interesting to a lot of our customers, where you get that phone call and it says, hey, the network's slow or the network's down. And of course, if you guys are network guys, you know that story, and you got to prove that it's not the network, it's something else. So this is App IQ, where I go in and I can select an endpoint, an instance. Let's say this is the app server, and then I connect in to the database server. And what this is going to do is it's going to run a report. This usually takes about 20 seconds to run, but I've speeded it up so we can see the result. And now I can see this is the instance that I selected. That's the other instance I selected. This is the entire path that it would take. And you can see the equal cost multipath. One of these links is down, you can see, so maybe that's slowing something down. But then I can look at each one of the devices in the stream and see if there's any performance issues with any of those network devices. And then this is really powerful coming up here. I should have stopped this earlier, but so we're looking at things like network ACLs and route tables and security groups, and this is all going in one direction, and then it comes back in the other direction. So I now can look at all the network ACLs, there we go, network ACLs and route tables and security groups, and you see that I had a fail on the security groups here. So I've identified that there's not a security group available for that communication coming back that quickly. This report comes up in about 20 seconds, and it would take 12 different windows in the AWS console to get all of this information, and a lot of human correlation to kind of figure out that it was a security group that was the problem. Okay, let's talk a little bit about service insertion. So one of the things that we do with our partners like Palo Alto Networks and Checkpoint and Fortinet is we help them bring their VM versions of their firewalls into the cloud, and we automate all of the connections there, and we can do the scale out. And we will manage the connections to the firewalls, and as that scales out, we do bidirectional hashing to remember exactly which firewall that session is going through. So now that releases the packet, it goes here. When it comes back, we route it to the right firewall and then back to where it's supposed to be going. So you get that inspection, that bidirectional inspection for the service insertion of those firewalls. Now, we can also do this with the gateway load balancer. So if you've moved to supporting Geneve on your firewall and you want to use the gateway load balancer, we can insert that into this picture as well and still maintain all of the connections without having to do SNAT or IPsec connections. Okay, so then now let's talk a little bit about overlapping IP spaces. This is something that a lot of our customers do that connect to their customers. So for instance, Centene connects to a bunch of different hospitals, and they run into overlapping IP issues with their customer. We have a very elegant way of dealing with this, where you need to just enter in the customer's destination IP address, the customer's virtual IP address, the cloud virtual IP address, and then the cloud destination IP. So the only thing that you give to the customer is the cloud virtual IPs. You say, this is how you talk to our service. Now what happens then is we push all the rest of these IP addresses down into our gateway. So when something comes from the customer, here we're going to do the natting that'll get it to the right place. We'll bring it back, and then we'll do the denatting so that it gets sent back to the customer in the right way. And so this is a very simple and elegant way to be able to maintain the visibility and be able to see everything that's going on. Now we'll talk a little bit about guard duty. So there's a few components in this picture where there's guard duty that has information like we have from Proofpoint about malicious IPs. We have the Internet Gateway Ingress Routing service from AWS. We have our controller and we have our gateways. So what happens is our controller reaches out to Amazon Guard Duty and gets those malicious IPs and then pushes those into our gateways. So now when the traffic comes in from the internet, it's going to be routed to our service by the ingress routing service that now we're going to have stateful firewall rules that block those malicious IPs already. And if it passes, it'll be able to come in. If it doesn't, it gets blocked. And then in terms of network segmentation, we can do some interesting things across clouds. So for instance, I could have all my different things that my internal teams can get to all my VPCs and my VNet in Azure, but I might have a partner that I only want to have access to this VPC, so I can set up the rules to be able to do that. Or I might have a customer who I'm running customer applications in both AWS and in Azure, and they would have access to either of these. So for instance, to be able to, if one of the environments went down, I'd still have access to the application in another environment. So to find out a little bit more, we're in a booth right over here. Stop by and talk to us. We also do network immersion days with AWS on a regular basis, where these are like workshops. You can actually get in and see how it works, or go to our page and join one of our builds, our flight schools, or even ACE. ACE is our certification program, sort of like a CCIE, but for multi-cloud networking. And we've had about, as I mentioned, 17,000 people go through that program already today. We get a lot of feedback on it. It's a 4-hour, the base level is a 4-hour online self-paced class. You get a cert after it, and we're giving away a free code in the booth if you want to come get that. But it's focused not all on Aviatrix. It actually talks about how you do networking in Azure, how you do networking in AWS, how you do networking in Google. So you get a kind of a taste of multi-cloud networking, and we tell you all the things that they won't tell you, and then we show you how Aviatrix can solve those problems. So I'll be around for some questions if anybody has questions. But with that, thank you for coming to the session.
Thank you so much, Rod. Thanks, everybody.